Good afternoon, everyone. My name is Daniel Wright, and today I'll be talking to you about my project, which is high temperature secondary lithium-ion batteries. And what might count as high temperature, it's anything up to 150 degrees C. So what are the applications for this? Well, typically at the moment, the drone industry uses primary batteries to go up to about 150 degrees. These are typically in sensors and things like that. And at the moment, the market is restricted to either primary cells or sodium sulfur. However, sodium sulfur is restricted to stationary applications, and lithium phenol chloride primary batteries are just throwaway at the end of the day. So there is a drive to replace this. However, this is quite a challenge due to the instability of the electrolyte interface. So far my project has looked around changing the binders and then went on to looking at electrolytes. So these were carbonate-based electrolytes with alternative lithium salts in them, and so I've tested these at a range of temperatures going from 60 degrees up to 150. However, you can see that this performance at 60 degrees is good, even at 90 degrees. However, you may observe on this first cycle that we have some process happening here, which results in actually a large capacity. However, this is not true capacity, and this can be observed actually going at 120 and 150 degrees as well. And you can also see that the capacity fade really does decline quite quickly at 150. So we want to try and understand actually what is happening at these higher temperatures. So there's going to be some further analysis on these at these temperatures. So we're looking to do some surface analysis, so SEM and TEM, and looking at the electrode surfaces for SEI formation and kind of loss in stability of the electrodes. So we're looking for if the electrodes are still intact or not. And then to look at doing some chemical studies of the electrode surfaces as well. So to look at doing XRD and XPS, actually to look at the electrolyte breakdown products, and to also look for changes in the binder and active materials. And lastly, some ICP analysis to actually look at the metal content of the electrolytes. So at higher temperatures you can get dissolution of the cathode materials, for example, and we would be able to look at this. So the real idea is to actually work out whether it's an electrode problem or it's an electrolyte problem, and be able to focus the research in this kind of direction in order to improve the high temperature stability and get better performance at higher temperatures. Thank you. Does anyone have any questions?